This is a video on interpreting quadratic functions, and I'm going to look at two examples in this video. For my first example, I'm using two functions, f of x and g of x. F of x is x squared minus 4, and g of x is minus 1x minus 2. I've graphed these functions in the range minus 3 up as far as 3. So what I would suggest that you do before you go any further is actually take these two functions and graph them yourself in this domain, and then come back and watch the video again, and we'll go through the questions that are being asked about the graph. Okay, so we'll start off with some things that we've seen before. First of all, I want to find the roots of f of x. So first of all, I need to identify f of x, which is my quadratic, and I want to figure out where it goes through the x-axis. Now notice I've seen the roots where f of x equals to 0, so they definitely mean the x-axis in this case. I can see quite clearly the solutions here are x equals minus 2 and x equals 2. Okay, part 1 is finished. The second part of the question says find the roots of f of x equals 5. So I know that I'm looking at the quadratic still because it's f of x. Now, just watch out here. They are saying the word roots, but they're also saying f of x equals 5. So in this context, roots just means solutions, and specifically solutions for x. F of x equals 5 means that I need to go to 5 on the y-axis, and with my ruler I want to draw a line through that horizontally. This line touches my quadratic curve in two places, and when I drop down then from those 2 points to the x-axis I get my solutions, and in this case it's minus 3 and positive 3. The next part of the question asks us to find the values of x where f of x equals g of x. Now, f of x is the curve and g of x is the line. And f of x equals g of x just means where are f of x and g of x in the same place. So I'm looking for their point of intersection. And it's just the x bit of this that I want. So I can see that these two functions intersect at this point here, which is actually on the x-axis. So I haven't got to even travel to find the x value. I can see straight away it's minus 2. And also here at this other pink dot. And if I travel up to the x-axis for this, I get a value of 1. So my solutions for this are x equals minus 2 and x equals 1. Okay, so part 4 says find the range of values of x for which f of x is less than g of x. So a couple of things just to watch out for here. First of all, they're looking for a range of values of x. If they use the word find a range of values, so the word range, that usually means that they want you to use greater than and less than symbols in your answer. And you can actually see that there are greater than and less than symbols used in the question as well, for a question of this type. Okay, and they want us to find where f of x is less than g of x. In the context of a graph, less than means below and greater than means above. So they're asking us to figure out where is f of x below g of x. Now let's look at our diagram for a second. So f of x is the curve and g of x is the line. So where is f of x below g of x? I'm going to highlight that region of the graph. So the section that I've highlighted in pink here is where f of x is below g of x. If you were at any point on f of x down here and you looked up, you'd be able to see g of x above you. So now what I want to know is where does this portion of the graph begin and end? So it begins at minus 2, and I'm always referring to x values for my answers here. So minus 2 is where it starts. And when I get over here, as far as this point, well, the x value for that we already established as 1, so it finishes at 1. Now, I need to use inequality symbols for my answers. So what I'm going to do is I'm going to take my ruler and I'm going to line it up with each of the x values. So I'm going to put my ruler down first of all for the x equals minus 2. So I'm just trying to straighten it up there so we can see both sides. And I need to decide, okay, have I highlighted part of my graph to the left of the ruler or to the right of the ruler? If it's left of the ruler, I'll use less than, and if it's to the right of the ruler, I'll use greater than. So you can quite clearly see that the pink highlighted part is to the right of the ruler in this case. So I'm going to use greater than, and the value that I had the ruler going through was the minus 2, so x is greater than minus 2. Okay, so I've gone now to the other end of the region that I've highlighted, and I'm putting my ruler straight through the 1, as you can see there on my x-axis. So again, I'm making a decision. Is my shaded region to the left or to the right of this? If it's to the left, it's less than. If it's to the right, it's greater than. And clearly the pink highlighted section is to the left of the ruler in this case. So my answer is going to be x is less than 1. You might not need to use the ruler at all in order to make the decision for these symbols. but it can be a useful visual aid because you can quite clearly see when you've put the ruler down vertically through the x value, whether it's been shaded for the region that you want to the left of that or to the right of that. So it can make things a little bit easier. So part 5 is quite similar. It says find the range of values of x for which f of x is greater than g of x. So this means that f of x, my quadratic curve, has to be above g of x, the line. Okay, so if I want to have a think about where I would need to be on the curve to be over the line, well, I've already highlighted the region where I'd be below the line, so it's just the remaining parts of the curve. So I've highlighted in orange the parts of f of x that are above g of x, and you can see that if you were on any of these orange parts of f of x and looked down, you'd be able to see the g of x line below you. So I'm definitely above the line above g of x. Okay, so actually the values where this stops and finishes are actually the exact same as for part 4 of the question. So from -2 back this way, I'm above g of x, and from 1 going in this direction, I'm above g of x. So you can use the same ruler trick again as before if you like. So just take your ruler and line it up with the starting point of the shaded region, and note the x value that you're going through. So I'm lining it up with the -2 again this time. And you'll see that the region that I'm focusing on in this case, the shaded orange region, is to the left of the ruler. So I'm going to say less than -2. And when I line my ruler up with the 1 at the start of the orange section and have a look, I can see that it's to the right of the ruler that my orange shaded section lies. So that means I'm going to use the greater than symbol. So it's x is greater than 1. Finally, sometimes we'll encounter a question where we're given a function, like in this case x squared minus 5, that is very like a function that was given in the question. So for example, our f of x in this graph is x squared minus 4. But this is very like it, but it's not exactly the same. It's x squared minus 5. And we're being asked to use the graph to solve this, but how can I? Because I don't have x squared minus 5 on the graph. Okay, so if something like this happens, what I tried to do is I tried to make the equation that they're giving me as much like the original function as possible. So how could I do that? Well, I don't want -5, I want -4 instead. So to get from -5 to -4, I can add 1. But of course, with an equation, I can't just do something on one side, I have to do it on both sides. So I'll add 1 on the right-hand side as well. So now I can tidy up what I have here on the left to be x squared minus 4, which I know is my f of x function. And the right-hand side is just 1. Okay, now like I said, x squared minus 4 is f of x. So instead of writing down x squared minus 4, I'm going to write down f of x instead. Okay, now we know what to do with this because we've seen it previously. So f of x equals 1 means that I go to 1 on the y-axis. And I put my ruler horizontally and I draw a line through it. In fact, this is just like part 1 and part 2 of this example. So I'll draw a line through it and I go out until I hit the curve. And then I drop down to the x-axis. And where I land on the x-axis then is my solution. So I've got about -2.2 and plus 2.2. And those are my solutions for that equation. In example 2, I'm given the graphs of 2 different quadratics, and they're called A and B on the graph. And I'm told that one of them is f of x and one of them is g of x. And I'd like to know which is which. How might you be able to tell? Okay, well, don't forget that, of course, a quadratic will go through the y-axis at some point. And I can see here that A goes through the y-axis at 2 and B goes through the y-axis at 4. So is that of any use to us in figuring out which one is A and which one is B out of the f of x and g of x? Well, remember that just like the equation of the line, the constant at the end of your quadratic tells you its y-intercept. So here I can quite clearly see that f of x has a y-intercept of 2 and g of x has a y-intercept of 4. So now it's really easy to identify which one's which. A is f of x and B is g of x. Next, we're asked to find one value where f of x equals g of x. But of course, again, when we say that two functions are equal, what we're really saying is that they're intersecting. So what do you think I should write as the answer for this? Well, I first of all mark the point where they intersect, and then I drop down to the x-axis to get my value. And this time it's approximately 1.7 or 1.8. I'm going to say 1.7. Remember that in all cases where you're reading from a graph, you're estimating. They'll allow you a little bit of wiggle room, but try and be as accurate as you can. So in part 3, I'm being asked, does f of x have roots? Now remember that f of x is the graph A. So looking at A, what do you notice about it? Well, it's always positive, by which I mean it's always above the x-axis. Well, in order for a function to have roots, it needs to go through the x-axis. So this particular quadratic doesn't have any roots. If you want to be particular about it, you'd say that it has no real roots. Part 4 of the question, why does g of x equals 0 only have one root? There's a couple of different ways in which you can answer this question. So first of all, on a visual level, if we look at our diagram, we can see that g of x, which is the B curve, only touches off the x-axis in one place. So there's only one root because the function only meets the x-axis in one location. If you wanted to phrase that nicely, you could say that the x-axis is a tangent to g of x. This just means that the x-axis only tips the gx in one place. You might remember earlier we were told that g of x was x squared minus 4x plus 4. So we could also take an algebraic approach to this. If we were to factorize x squared minus 4x plus 4, what would we get, do you think? Take a moment to go away and work that out. When you factorize this quadratic, you get the same factor twice. So you could also give us an answer that g of x only has one repeating factor, so it has one root.